The Parseval identity formula is integral minus L to L modulus f of x the whole square dx is equal to a naught square divided by 2 plus summation n is equal to 1 to infinity a n square plus b n square. So this is for the limit minus L to L. If the question is 0 to 2 pi, we use 0 to 2 pi. And it is minus pi to pi, then we use minus pi to pi. According to the limit, we can use this integral. For even function, we get only a naught and a n. In such cases, we use a naught square by 2 plus summation n is equal to 1 to infinity a n square. Suppose the given function is odd, then a naught and a n equal to 0. So we use only this b n square, that is, in such cases, integral minus L to L mod f of x whole square dx is equal to summation n is equal to 1 to infinity only bn square. So let us do one problem. Find the Fourier series representation of the function f of x is equal to x square in minus pi to pi. So here the limit is minus pi to pi. So we use the formula minus pi to pi only. So first part is same to the previous method. You have it to find a naught, a n and bn. Here f of x is equal to x square is an even function because its power is even. So it is an even function. Therefore bn is equal to 0. So we have it to find only a naught and a n. So what is a naught? 2 by pi integral 0 to pi f of x dx, and a n is equal to 2 by pi integral 0 to 2 pi f of x cos n x dx. Now first part, that is a naught value is equal to 2 by pi integral 0 to pi x square dx. Substitute in this formula and apply the limit, we can get a naught is equal to 2 pi square by 3. So what is a n? So a n is another next formula, that is a n is equal to 2 by pi integral 0 to pi x square cos n x dx. Now u equal to, this is polynomial and this is trigonometric function. So we use product rule formula, that is u is equal to x square. Here power is equal to 2. So we use 2 differentiation and 3 integrations. So v1 is equal to sin nx by n. Then v2 is equal to minus cos nx by n square, and v3 is equal to minus sin nx by n cube. So this is the integral values. Cos integration is sin, then sin integral is minus cos, and each step we can get one constant of the coefficient of x in the denominator. So this is the parameters we have it applied in the given formulas. Now therefore a n is equal to 2 by pi u into v1 minus u dash v2 plus u double dash v3. The limit is 0 to pi. Now substitute the values, that is x square into sin nx by n minus 2x into minus cos nx by n square plus 2 into minus sin nx by n cube. Then the limit is 0 to pi. Here, since the limit is 0 to pi, we can cancel sign terms. So these two sign terms will be cancelled. Now here minus 2 by n square, that is minus 2 by n square. There is one minus into minus plus. So 2 by n square we can take as a common. So the remaining only x cos nx. Apply the limit, that is upper limit pi cos nx minus lower limit. When you put x is equal to 0, this lower limit will be 0. So there is only remaining 4 by n square pi into again pi into cos n pi. What is cos n pi? That is minus 1 raised to n. Therefore, this pi cancel, we can get 4 by n square into minus 1 raised to n. Now, what is f of x? So f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity a n cos nx plus bn value is equal to 0. Since f of x is even, bn value is equal to 0. Now substitute all these things, that is 2 into pi square by 3 by 2 plus summation n is equal to 1 to infinity 4 by n square minus 1 raised to n cos nx. Now this 4 is a constant. We can take it outside from the so this is equal to pi square by 3 plus 4 is a constant. We can take an outside, that is n into summation n is equal to 1 to infinity minus 1 power n cos nx. So this is the regular solution for the Fourier series. Now Parseval's identity. Why we have to apply Parseval's identity? Because here we have n square only. When you put n is equal to 1, we get 1 by 1 square, 1 by 2 square, 1 by 3 square only. But our required answer is 1 by 1 raised to 4, 2 raised to 4, 3 raised to 4. So in such cases, we can apply the Parseval's identity. So the question will not contain use Parseval's identity. You only identify the question. So by Parseval's identity, this is our formula. So we can apply the Parseval's identity. That is 1 by pi integral minus pi to pi mod f of x whole square dx is equal to a naught square by 2 plus summation n is equal to 1 to infinity a n square. Now what is f of x? That is x square the whole square. That is x raised to 4. X raised to 4 integration is x raised to 5 by 5. Then what is RHS side? A naught value we can substitute here. A n value here we can substitute. So here cancelling you can get 2 pi raised to 4 and plus here 16 into minus 1 raised to n whole square is equal to minus 1 raised to 2n. Minus 1 raised to 2n, that is all the power of this minus 1 is even. That means you will get 1 only. So 16 into summation n is equal to 1 to infinity 1 by n raised to 4. Now we can simplify the value. Now 2 by 5 into, here cancel you can get pi raised to 4 by 5. You take this term to LHS side, you can get 2 pi raised to 4 by 9. That is equal to 16 into summation n is equal to 1 to infinity 1 by n raised to 4. Now dividing by 2 because these two here 2 common and here also we can divide by 2. So totally you divide by 2 pi raised to 4 minus pi by 5 minus pi raised to 4 by 9 equal to 8 into summation n is equal to 1 to infinity 1 by n raised to 4. Simplifying you can get summation n is equal to 1 to infinity. This value is equal to 1 by n raised to 4 equal to pi raised to 4 by 2 into 45. Pi raised to 4 by 2 into 45. That value is equal to pi raised to 4 by 90. So here we get the n raised to 4. So put n is equal to 1, we can get 1 raised to 4. N is equal to 2, we can get 2 raised to 4, etc. So that value is equal to pi raised to 4. This is our required answer. Now let us